Okay, so this is my answer to discussion number 5. So for this discussion, we are to prove that well, if lambda is an eigenvalue of A, we are to prove that lambda squared is an eigenvalue of A squared. So for this example, I'm going to use I made a numerical matrix. I tried doing it in the form of, A11, A12, A21, A22, but it didn't work out. Well, I mean, it worked out. It worked, but it's not. I'm not going to write that on my whiteboard. It's very long. So I'm going to use numerical matrix to prove this. So we're going to do. We're going to do the first step. We have A. We're going to use A. We're going to write A minus lambda I. So for this, we're going to write our matrix like this. We get 3 minus lambda, 1, 6, and 2 minus lambda. All right, very easy. Sure. Now we're going to solve for now we're going to do the determinant of this form right here. So we get, I'm going to write that actually over here. Determinant of A minus lambda I equals this. Now, when we do the determinant, we get 3 minus lambda times 2 minus lambda, and then 6 times 1 is 6, so go subtract 6. All right, so now we're up to this part. We set the determinant of A minus lambda I equals 0, which means, all right, so then we do the little FOIL action. We get 6. We get 3 times a negative lambda, it's negative 3 lambda, negative 2 lambda, and then plus lambda squared minus 6. Okay? So now we combine like terms. So 6 minus 6 is 0. Negative 3 lambda minus negative 2 lambda is a negative 5 lambda. And then we have lambda squared. All right. So now, to get our lambda, figure out where our lambda eigenvalues are. We factor out lambda out of this, minus 5. Then we get 0, or actually, we just say 0, or no, lambda equals 0, and lambda equals 5, right? So these are our eigenvalues of our matrix. So now, what I'm going to do is I'm going to multiply this matrix, or square it, and then do the same process again. So let's do that. So A times A equals 3, 1, 6, 2, which equals, I'm not going to have enough room here, which equals 3 times 3 is 9, plus 6, because 1 times 6. First value, 3 times 1 is 3, plus 3 times 2 is 2, or 1 times 2 is 2. That's 6 times 3 is 18, plus 6 times 2 is 12, and 6 times 1 is 6, plus 2 times 2 is 4, which equals 15, 5, 30, 10. So that's our AA squared. So I'm going to set A squared equal to B, just for the heck of it. So it'll make this easier to solve, or make it more cleaner. So the determinant of, well, actually that's fine. That equals first before I actually even do a determinant. So B minus lambda I equals, so now we have B minus the lambda times I. We're going to do this, 15 15 minus lambda, 5, 30, 10 minus lambda. Find the determinant of that guy. Means we get lambdas look like x's. There we go. And then, all right, so then we got 15 minus lambda times 10 minus lambda minus 150. So that's this up here. That's actually similar to this after we FOIL it. So the determinant of b plus lambda I equals 0, set equal to 0. Get 150 minus 15 lambda minus 10 lambda plus lambda squared minus 150. So then we get 0 this out because that makes 0. And then we get lambda squared minus 25 lambda over here. And now, well, this is we get pretty much our answer right here. So then our eigenvalues of this matrix is 0 and 25. Easy. So then this proves our point that lambda, if lambda is an eigenvalue of a, lambda squared is going to be an eigenvalue of a squared. And that's what we got right here. Just because, 0 times 0 times 0 is 0, 5 times 5 is 25. So this is my proof to my answer. That's the answer, my answer. And that's all there is.